Welcome everybody to our presentation today. I am going to help transition us into the beginning here of our 5G crash course. This is the first time we presented the 5G crash course, and we as RCN, we are a company here in Knoxville, Tennessee, but we have nationwide coverage for clients. We have installed in all 50 states, and we're really good experts in the kind of wireless wide area network. And so we also have, let me advance the slides here. We have a motto here that you can expect more from your technology ally. We want to be your technology ally. And this is a new series that we're starting, and we'll continue all through 2021 of 5G webinars. So if you're interested in 5G, how it works, how it can apply to you, just keep staying tuned, and we'll keep providing you quality information and content on that. Today we have me and Jacob. So I'll introduce myself. I'm the Director of Marketing here at RCN, and we've started a 5G task force specifically to enable our entire company to better serve our customers and serve with our partners. You know, we partner with the major US networks. We partner with the major manufacturers who are developing 5G solutions today. And so our 5G task force brings all that information together and tries to find ways to benefit our audiences, specifically our customers, and try and help them with that 5G process. So I'm on that task force as well. Mr. Perry, you want to share a little more about yourself?
Yeah. My name's Jacob. I'm the lead engineer here at RCN Technologies. I'm also the engineer of the 5G task force, and that's basically it.
He sells himself short just a little bit, but Jacob is pretty incredible. He's really well versed in this, and we are learning more every day. Just so you guys know, we actually had a call 2 hours ago and got some really in-depth information from T-Mobile about some of what they're developing. So can't share everything, but we'll share what we can.
Yeah, absolutely.
So Jacob, why don't you walk us through our presentation today, what we're going to cover?
Yeah, absolutely. So we're going to start off with just looking at the differences between 3G and 4G. I think to better understand the transition we're going to watch happen between 4G and 5G, it's good to look back at a transition we've already experienced and know all the data from. From there, we're just going to kind of go into the flavors and the specs of the low band and high band of 5G, what you can expect and what we're seeing in today. From there, we're going to go into kind of what the carriers are talking about, what they have currently, what they're trying to roll out, what they hope to do in the future. We're going to take just a tad touch into security. It's a very broad section with 5G. There's a lot to talk about in security. So we're hoping to say more about that later, but for now, we'll touch on it a little bit. And then we're just going to go into what's possible with 5G. Not necessarily what we're definitely going to see, but what it unlocks as a technology, and what's kind of been holding us back from a lot of that technology that 5G is going to allow us to move forward. And hopefully we'll have some time at the end to just do a quick Q&A and ask any questions that you guys may have, and hopefully we'll be able to answer them.
All right, thanks, Jacob. And just so you guys know, at the end, like I said, we're going to share the notes, the slides. You also get a discount code. So if you're interested in 5G solutions for your organization, then we'll provide some information about how you can do that. But that's not why we're here today. It's just a benefit of you for attending. We're going to play a little game here, a little fun. We call it the 5G propaganda game. And we really want to know how well you know 5G, from what 5G actually is to what you think it might be based on the marketing and advertising you've seen. So it's going to be really quick. We got 3 quick questions we're going to go through. I want you guys to engage and vote with this. We want to know what your thoughts are. If you have any questions about what we're doing, drop them in the chat. But our first question, Jacob, and I'm going to ask this to you, and I want you to give us a little explanation on it as soon as we get a couple of votes in. 5G speeds are the fastest wireless speeds we've ever seen. We're going to go ahead and start that one, see what everybody thinks. I'm curious to see what your explanation is, Jacob, on this one.
Yeah, I'm more curious to see how many votes we get for each way, see what the people think.
All right, we'll give a couple more seconds for you guys to log the true or false. And it's interesting so far. It looks like we're going to have a 60-40 split or close to it.
Tipping the scales to true a little there.
All right. All right, Jacob, you want to explain to us? It looks like we had 66 true, 33% were false. What's the truth here?
So if I had to give a solid answer, I'd probably say true. But the fact of the matter is that it's really true and false. We have. It is a little bit of a trick question. Might be a trend. We'll see in the low band area, we'll get a lot of the benefits of 5G that we're going to go into a little bit more later. But we may still see similar, if not the same speeds that we have with 4G LTE today. And in some areas, sometimes even worse speeds. And that's okay because of all the benefits we get after that. But of course, with millimeter wave, we're seeing possibilities of 1 to 10 gigabytes per second, which is just insane. So it's a little bit of both.
Okay, all right. All right, let's go into question 2. Thanks for teasing us on that one and giving us a fake question. All right. You will need to get new hardware in order to access 5G networks. True or false? Ooh, interesting. Split so far is up. It's starting to lean one way now. Okay. So it looks like the people are saying true, Jacob, with about a 70-30 split here. And maybe it's building a little bit more to 80. That's what the people say. What do you say?
So if I was once again to pick a hard answer on this one, I'm afraid I'm going to have to say false. Because in today's world, not only do we have carriers doing a lot on the back end to integrate their 4G and their new 5G infrastructures together to make it possible for your 4G LTE phones today to be able to access and unlock most of the benefits that 5G offers. But as we roll forward and as we move into the future, we will see dedicated 5G standalone networks that will require its own frame of hardware, but we're probably going to see that further into the future.
All right, still a great question. All right, last one. Here we go. All right, high band millimeter wave is not practical because of the short travel distance. True or false?
Ooh, starting off with a false on this one.
I feel like I know the answer to this one. I hope you're not toying with me this time like you did on the other two. All right, we're pretty evenly split. The people are saying 50-50. True or false? What's the truth?
Well, I'd say the people are correct because, I'm sorry, Ben, but I've done it to you again. This is a little bit of both. I think the biggest thing about people thinking about millimeter wave as being impractical because of how short of a distance it can travel is because we're still thinking about it as a normal cellular wave coming from a tower way off in the distance. When in reality, we really need to get closer and think about those cellular antennas inside shops, on streets, places like that. That's where we're really going to see the high band start to shine. But until that happens, we're not going to see it shine as much.
Okay, all right. Well, that wraps up our 5G propaganda game. I hope you guys had some fun playing with that one and voting and getting duped by our engineer Jacob here. We're going to move on to our first big section here. It's wireless network evolution. We're going to talk a little bit about some key terms you need to know related to the wireless network specifically as 5G makes an impact. We're going to talk a little bit more about the history of our wireless network and the evolution through to the current state, and then some improvements you can expect. So, Jacob, I'm going to pass the baton to you real quick and let you explain some of these words to us so that we understand and can speak 5G.
Yeah, so these are some of the terms we're just going to be using throughout this presentation. It's important to know exactly what we're talking about as we move forward. So first of all is capacity, pretty simple. Just the amount of clients that can be held on a single cell from a cellular network. So, and that's pretty much the long and short of capacity. We'll go into deeper detail about what that means for 5G later on in the presentation. And so bandwidth, the way I like to describe it is a lot of people think bandwidth equals speeds, but really bandwidth equals the road. So just because your road is 8 lanes wide doesn't mean that a car is going to go any faster down it. It just means that it has a lot more room for a lot more cars. And so bandwidth is going to be really important for transfers of large amounts of data. And that's why it is important, because if you have the fastest internet available but don't have enough bandwidth, then it's not of much use.
All right.
And then latency, pretty plain and simple, just the amount of time it takes to send that data. A lot of people see this as speed and kind of wonder what's the difference between speed and latency. Latency is how long it takes to start, essentially. So if a car goes 0 to 60, like we have a little graphic here, 60 is its top speed, which is what we're talking about in speeds. But latency is how long it takes to get from 0 to 60.
That makes it easy for people like me.
And so frequency is a term, if you've been in the 5G news, it is a term that is used very, very often in talking about low, mid, and high band. And what the biggest difference is between them, and people mostly talk about, it's frequency. And although that is a very, very important part of speed, of latency, of the different interactions that go into cellular, it's still not the most important. But it's important to know that this is just how we measure how many waves are between 2 lines at a given period of time. The higher the frequency, the more it's fluctuating. And often that means the faster it'll move, but not always.
All right, and our last one here.
This one we're gonna touch on a little bit. This is less something to know for later on and more just something that I think needs to be defined, because it is a buzz term that's been spreading around a lot. Dynamic spectrum sharing is a really, really excellent technology that is actually going to allow what I was talking about earlier with that new hardware. And it's going to allow us to use our 4G devices as 5G devices and allow them to accept 5G via just software updates.
All right. So explain to us a little bit about the evolution here, Jacob.
Yeah, absolutely. I really love looking at the difference between these two, because of course we can tell 3G has a speed of less than a meg, up to 5 meg was its top end. Its latency was 100 to 500 milliseconds, which is really, really slow. And then, of course, we look at 4G, 10 to 100. 100 is very useful, rarer to get with LTE, but it is very, very possible. And we also got a latency of usually less than 100 milliseconds. So we got a lot faster with it. But what I love about this slide is actually looking at the frequency ranges. So 4G's low-end frequency range actually starts below 3G's. And all this means is just what frequencies these bands are tapping into. It really doesn't, more frequency doesn't necessarily always mean more speed, though it does play a part. And I think seeing this juxtaposition between these two really shows that point off.
All right, and let's add in some 5G and show some of the methodology here behind the evolution.
Yeah, so one of the most amazing things is looking at how much our world has changed ever since 3G, and even a little bit 2G before that. These technologies, a lot of people think were a representation of the technology itself, and they absolutely were, but it couldn't get anywhere without the technology to back it up, which is the carriers and which is the cellular strengths. So thinking about it that way, you can say we wouldn't have smartphones. Social media wouldn't be as explosive as it is today without the ushering in of 3G. And then, how many of us today are watching streaming sites, YouTube, things like that on our phones, our iPads, on the train, on the go, anywhere. 4G was what made that possible. Both of these things, the introduction and the transition of them, completely changed our lives in very small ways that whenever you take a step back and really look back on them, it's amazing to think about the world we'd be in today if it wasn't for these technologies. And so that brings us to 5G, and knowing how much these carriers have changed us in small ways, or how much these technologies have changed us in small ways, we can kind of expect the same from 5G. It's very exciting and it's all very explosive at first, talking about it, but it is going to take time for the technology to catch up with it. It's going to take time to roll out the infrastructures, and we're going to see very small incremental changes that are going to completely change our lives for the better. And so going into the nitty-gritty just a little bit, we saw the slide earlier between 3G and 4G. Well, what does 5G offer us? So here's sort of the whole spectrum laid out, a graph I'm sure a lot of you have seen a few times now, of low, mid, and high. Low band is your close to 4G LTE speeds, sometimes going above and beyond it. We can get up to 200, 250 megabytes, but it is going to be a little rare. The important thing about low band is going to be how far it can travel. Low band can travel an extreme distance, and so one cell tower in the middle of a town can provide internet to an entire town with low band. And so moving on to mid band, we're going to see a lot better speeds, kind of bumping up against gigabit speeds, but not quite there. It isn't going to travel as far, but it's going to give us a lot more speeds, and really it's going to give us the best of both worlds between the high band and the low band, which brings us over to the high band. And for this, we're going to see much, much, much faster speeds, but unfortunately, it just can't go the same distance as the mid and low bands. And it can also be interrupted pretty easily. And so like I mentioned earlier in the webinar, we're going to need to rethink cellular technology and stop thinking about it as those blinking red lights we see on the tops of hills in the distance and never get a close look at. And instead, over time, it might even be in our homes or in our offices and in our businesses, which is going to be really, really amazing. And I think that's where it's going to shine.
And Jacob hit on this just a second ago for a little bit, but there's a major difference here with the distance or the amount of area that a band can cover. Low band obviously being very far, mid band having some more limitations than low band, and then high band being very, very limited as far as scope and distance. And we were talking about this as we were putting this presentation together, trying to make it more tangible. So we've got a fun little illustration here. Follow us along. If you're a sports person, then this will hit home for you. If it's not, then hopefully you can play ball with this, so to speak. But we were kind of talking about, if we had to make an analogy out of it, right? Let's say we're playing baseball. You're at home plate. You got your bat, and your goal is to get the ball over the fence with a home run. And let's say you're using a traditional baseball. The fastest way and the best way to get it over the fence is to just swing the bat and hit it as hard as you can, and hopefully it falls on the other side of that fence. But that's one quick stroke. That's how far the ball goes, and that's kind of how the low band works, right? It's a lighter weight. If you're thinking, trying make it more tangible, lighter weight, it goes further because it's not as heavy, so to speak. So pretend like low band is the baseball there, right? And then if we move along through this analogy, let's pretend we're playing the same field, but now we're playing with a basketball, right? So the ball's heavier, it's bigger, it's harder, it doesn't travel as far, right? So the pitcher's throwing, I know this is weird, but the pitcher's throwing a basketball at you, right? You can't hit it over the fence. There's no way you're going to hit with a baseball bat a basketball from home plate over the outfield fence. So you're going to need a little bit more help. So let's say you hit it, maybe past the pitcher, maybe you get to an infield, and then somebody else is going to have to hit it again and have to hit it again. And maybe you have, 8 to 10 people, and you finally hit it over the outfield fence. And that's kind of how you're going to have to relay that mid band. And so that's it's going to need more of those points to travel as far. At the same distance that the low band did, it's going to need more help. And then if we kind of keep going with this analogy, 5G millimeter wave or high band is a bowling ball, and it's probably going to break your bat if I'm going to be honest, and it's not going to go very far. You're going to need a whole lot of help. You might need 100 people lined up in an assembly line from home plate to the outfield wall just to get coverage in any type of the same capacity or same distance as a lower midband would. And you'll need more hardware, a different hardware, just to do it. Jacob, you could probably dig in a little bit more on that piece of the analogy.
Yeah. So hitting a bowling ball with a baseball bat will most definitely shatter your baseball bat. And for that reason, we're going to need specialized tools. And I talked about having smaller 5G antennas within buildings and on streets, but we can also project millimeter wave with massive MIMOs, these huge cellular antennas that are going to be on tops of buildings and on tops of other things that will allow us to give high band speeds to maybe not an entire suburb, but to an entire city. But we are going to need to change our infrastructure and change the way we're thinking about it in order to get there.
And Jacob, just for those of us who may not be as familiar, can you explain what MIMO is, or massive MIMO?
Yeah, MIMO is, gosh, the term has completely left my memory. The acronym MIMO, as typically happens with these things.
The idea is about the antenna array and the projection of that signal, correct?
Yeah. So it's multi-input, multiple output is all it stands for, and it's just antenna arrays, exactly. And so we're starting to coin the term, instead of MIMO, it's MMIMO or MMIMO, which are, instead of one ball antenna or one face antenna that you see in places every so often, we're going to see cells of antennas, big families and groups of antennas on top of buildings that are going to project and also reproject 5G.
Okay. Well, thanks for digging in that a little bit there, and I hope that makes sense to you guys, trying to make it, again, a little bit more tangible. Our next section here, we're going to cover a little bit more about 5G and the carriers, some of their branded terms, so you can kind of understand how they fit into 5G as we've laid it out so far, the current state and future predictions. And to be fair to each of the carriers that we're going to cover today, we've got as current of an information set as we can possibly get. And so we've even done research as of this morning to try and make sure that this is accurate, or as accurate as we can be today, and is fair to each carrier. So let's start with T-Mobile as an overview. T-Mobile doesn't really have a whole lot of marketing fluff terms, right? So we'll get into what those might be on some of the other carriers, or how they might be calling something by another name to brand it for their network. But generally, T-Mobile is just 5G is all the bands. And they were the first standalone 5G deployment, or 5G core network in the US. For them, their 5G strategy at first was low band. They rolled out their low band faster than anybody else. They have more coverage in low band at 270 million people in the US than any of the other networks. But they're also really advanced with the mid band, and that's because they have spectrum. And we can dig into that in the Q&A if you want to dig into that a little bit more. But they have more spectrum than the other carriers do right out of the gate because of their merger with Sprint. So they have about 100 million, or they will by the end of the week and a half from now, is what they're projecting. 100 million US people covered. And then the high band is where they're kind of a little bit slower to deploy because they're so focused on the low and mid band. They do have about 7 cities that they have some millimeter wave or high band deployment in, but that's about it. For T-Mobile, what they're planning to do next is to expand that mid-band. They want the mid-band coverage to be at 200 million or more by the end of next year. And just so everybody kind of knows, 200 is kind of the watermark. It may be, I can't remember if it's exactly the watermark that the FCC requires for nationwide promotions, but generally that's kind of the litmus test. So if you're hearing nationwide coverage, then that should be about 200 million people. And they're expecting the average speed to be about 300 megabits, and that it can go up to a peak rate at gigabit plus. And they're going to continue, obviously, rolling a low and high band as well, but you won't see much high band impact from T-Mobile probably until mid to late 2021, the second half there. And that's kind of a picture of where T-Mobile is as of today, as best we can share it. Verizon's next up. Okay, so there are a couple of terms that Verizon uses, like ultra wideband. That just means high band or millimeter wave technology. And then 5G nationwide, when they refer to nationwide, it's just their low and mid band. So they don't have, nobody has 5G nationwide in the high band, just to be fair to everybody. The nationwide coverage will come in the low band first and the mid band second. Their strategy is similar from the low band perspective now. At first, Verizon was really working on that high band rollout, the millimeter wave, and that's why you see 61 cities there. It's almost 10 times as many as T-Mobile has, and they really led with that because high band has the high speed. And that's what a lot of you saw in their marketing, especially earlier in the year, kind of starting with the Super Bowl and then all the way through about Q4 when they started rolling out that low band. And all of a sudden, their average network speed went from really fast down to a more normal average in line with most of the other carriers. They have 230 million, people in America that they can cover with their low band now. And then mid-band's interesting for Verizon and the next carrier, AT&T. So they're bidding to get more mid-band spectrum so they can roll out more of a mid-band network. And mid-band is really where we're going to see a lot of gains as far as speed and latency for most of America. What's next for Verizon? They're going to expand that low-band footprint nationwide further throughout the country, and then the high-band coverage in their current cities. They're telling us that essentially that they have 61 cities with high band now. They're not going to really add 61 more. They're going to try and make the coverage of high band in those 61 cities greater. They're also going to be testing high band and millimeter wave technology indoors, which they're working right now. I've read an article this morning even talking about how they're working with some retail stores, including like an Apple store, for example, to see how they can get high band inside, which is really challenging with the way that the technology works. So they're also going to roll out a standalone 5G core network in 2021. They don't currently have a standalone 5G core based on what we have access to information-wise. And then our other of the big three, AT&T, 5G plus is a term that you'll hear from them. And it can be, I think they use the symbol, but sometimes you might see it as written out. But essentially that's their high band technology. And what's AT&T's, or what's interesting about AT&T with the high band is that they're really trying to reserve that 5G plus, that high band, for enterprise use only. So it's not going to be something that I don't think the consumer market is going to access through AT&T. And they refer to 5G as the low and mid band. And interestingly, and they got into some hot water for it, but they still use it. So it must still be interesting and comparable. But the 5GE, right? So that's a term they started rolling out, I believe, in 2018. It's basically 4G LTE, or it's comparable speeds. And that's why they call it 5GE, 5G evolution, is that the speeds that you get on the 5GE with AT&T is comparable to low band 5G. And so that's why they're able to use that marketing term. So you'll see those from AT&T. Their strategy is similar to Verizon's as well. They have a low band rollout, and 225 million folks are covered by their low band. Their mid band they're also bidding for right now against Verizon. Those are the two big bidders that we expect to get some more spectrum out of the mid band at the current auction that's going on. And high band, they have 36 cities of coverage for the millimeter wave. What's next for AT&T? They're going to work a little bit differently than the other carriers. Their focus isn't so much speed, it's more latency. They're really trying to get their latency under 20 milliseconds. And so that they've expressed that they're going to really focus on improving their latency in 2021. And the early phases of that standalone 5G core are starting to roll out now, but they're going to really expand on that in 2021. And to expand a little bit, just real quick on that mid-band auction. So Verizon and AT&T are trying to get more spectrum in the mid-band. The interesting part about it is that T-Mobile has it already, and they've already started rolling it out. And they've got such a head start that you're going to see a lot of impact from T-Mobile in that mid-band before Verizon and AT&T can even deploy, for the most part. Based on what we're gathering, that whatever spectrum that is acquired in this auction that's going on right now can't realistically be touched or rolled out for 12 to 18 months. So there's a significant gap there in the mid-band where there's going to be a lot of advances in speed and latency between the carriers right now, and will probably be around for at least another year. So another interesting thing about AT&T that's different than T-Mobile and Verizon, T-Mobile and Verizon are both looking at rolling out wireless home broadband services, which is really unique and something that 5G can enable even greater. But AT&T isn't. They're really looking to build out fiber more than the wireless home broadband. So those are some of the differences in the major and the big three carriers. And we also have a couple of interesting notes coming in, with some non-traditional players in this space, right? So wireless networks aren't just those. I want you guys to kind of think about, don't think about them the way you always thought about them, because there's some new technology here and some sleeping giant, so to speak, maybe, if you will. So we got three names here: SpaceX, Amazon, and Dish. SpaceX and Amazon are working in the low Earth orbit satellite game. What they're really working on is trying to get home internet access and essentially through satellite. And SpaceX has been launching LEO satellites throughout 2020. They're testing a beta service right now called Better Than Nothing Home Internet Service. Amazon's, like I said, rolling out some, and they got some FCC approval for this project that they're working on. And then Dish is on there as well, Dish Network. Dish is actually a kind of a wild card here. They own billions of dollars worth of wireless spectrum, and they also own Sprint's old prepaid business, Boost Mobile. So they've got some big pieces that could build a wireless network. They just haven't really done much with it yet. So we're not sure exactly how it's going to roll out. There are reportedly working on some pieces for a 5G network and testing one in Wyoming currently, but they've got a long way to go to turn that on. And that's kind of some disruptors that you can kind of expect from this perspective. So all that, putting all that information together and where things are going for the next 12, 18 months, we do have an interesting prediction, and I want to kind of dig into really fast, but that 5G networks are going to break up this monogamous carrier relationship that we're used to. It's built, 2G, 3G, 4G has built this very similar performance era. There's not been a ton of differentiation between the carriers. Maybe some coverage is better in your area versus another area, and that's why you choose a carrier, but you're generally working with one carrier. But I think in the 5G era, the carriers will have much different strengths, and you're going to need more than one carrier relationship to enable all the applications that your business or organization might need, whether it's one carrier for primary, one carrier for mobile devices, or one for high band speeds, high band needs, specifically, millimeter wave applications that just can't be done without the millimeter wave technology. So, you might theoretically have a construction site with a Verizon connection, so they can do some millimeter wave rollout and application, and then they have T-Mobile for their mobile devices, or maybe some general primary access. So it's going to be interesting to see how that rolls out. It's just a prediction. There's no method behind it yet. Jacob, did you have something you wanted to add there?
No, I completely agree with this, though. That moving forward, we are going to see that carriers are better at certain things, and I think we'll also see a lot more carrier aggregation. I think aggregation is something that's a talking point that's kind of getting pushed away through all the 5G buzz, but is very much a part of this prediction and about how we're going to start doing things moving forward, I think.
And then another prediction, Jacob, you dig into this one, bud.
Yeah, that millimeter wave will replace Wi-Fi eventually, to be clear. As we've talked about, millimeter wave still has a long way to go in terms of infrastructure. But as we saw on the Verizon slide, they're putting through tests to do millimeter wave inside buildings, and not just inside buildings, but on street lights, benches, parks. We're getting to a point where it's possible that instead of running over Wi-Fi in your coffee shops or in your homes and businesses, we'll see this instead for a few reasons. One is just the absolute breakneck speeds that come along with it. If you can have millimeter wave in your own home, then why even have fiber? And on top of that, which is going to lead us into the next slide here, is going to be the security. So as some of you may know, Wi-Fi is less than secure when it comes to a lot of things. I'm sure we've all heard little horror stories about, someone breaking into someone's accounts via their router that was unlocked, sitting in their home, situations like this. And a lot of this just has to do with the fact that Wi-Fi just kind of broadcasts freely. And if you have the know-how, you can sometimes get into it with millimeter wave. You're going to need the exact right thing in order to get a hold of it, which is going to make it way more secure.
Speaking of security, why don't you walk us through slicing?
Yeah. So we've talked a lot about low, mid, and high. Obviously high is something to really get excited about. But of course, we're still running into problems. So if we're having problems with the really exciting part, mid-band's kind of exciting, and low-band kind of sounds like some of the same, then a lot of us are asking the questions, what is there to be so excited about with 5G? And of course, lower latency. We're seeing much, much, much lower latency with 5G. But honestly, it's going to be this. It's a term that everyone's using is called slicing. Slicing is something that the carriers and everybody is doing via software-defined networking. So what that means is instead of having to do an entire network rollout, so let's say a new division is being built or a new suburb, well, an engineer has to go to that network infrastructure and sometimes pull things out, put things in, make it different in order to supply for that suburb. With slicing and software-defined networking, we're actually going to have a community behind these towers that will instead allow network engineers to essentially do what would take weeks or maybe even months to do a network infrastructure rollout, and they'll be able to do a few punches on the keys and maybe do it in less than a week. And on top of that, with this control behind the tower, we can also slice off pieces of the network. So we at RCN Technologies could have our own slice of the 5G network that nobody else has access to except for us. And the same can be said about other businesses and other use cases. Slicing is also going to allow us to allocate resources. So let's say we at RCN really, really need some lower latency, but somewhere over in another company, maybe bandwidth is really their problem. Well, with an entire community that you can change via software instead of hardware, we can say, okay, well, RCN gets this segment and they get this segment, and we can allocate resources to get people what they need and nothing that they don't. This is going to unlock expansion to be way, way easier, and it's going to make security way, way easier for us because there's just going to be less fault within the networks itself.
All right, thank you for breaking down slicing there. I don't understand all of it, but I do understand some of the cool applications there, and I really appreciate what they can do for us. So we've got about 15 minutes left. We're going to try and save some time for Q&A. So we're going to go through a little bit of future casting as quickly as we can so we can get to the questions you guys probably have. Real quick, and this is a big one as far as the revolution goes, capacity and some SIM card changes, and then some new applications we'll tease. Jacob, this is one of your biggest takeaways as we're building a 5G task force, and I'll go ahead and advance the slide, but tell us the story here.
Yeah, absolutely. So this is another thing where it's where you say, what am I supposed to be excited about? Well, this is a huge one. We ask ourselves, what's preventing us from having some of those cool things you see in future movies, whether it's fancy AR contacts or a flying car? And honestly, the answer is connectivity. A lot of technology is there for a lot of things, but we just don't have the resources to be able to connect everything we need to. But with 5G, we're going to be able to do that. So 4G can only connect about 4,000 devices in a square kilometer, which is a lot, but it's not enough for the future that we're hoping to build, right? With 5G, we're going to be able to connect, supposedly, over 1 million devices per square kilometer. That means anything can be connected to the internet. We can have an entire city full of just smart infrastructure. And not have to worry about having huge amounts of resources via 4G LTE to be able to contain that capacity. And so I think this fact alone is going to be one of the biggest things that changes in our world.
I'm excited to see what that enables as well. And then, building on that, right? So we can add a whole bunch of new devices to a 5G network. And this is actually from Qualcomm. Kind of just a graphic that demonstrates some of the things that 5G will bring us and the applications in big categories and big buckets. Some of the things that stand out to me, obviously we got 3 categories here. Massive Internet of Things, not just some sensors, but we can really expand on that with that million capacity in a square kilometer. You got mission critical control applications, particularly around reliability and security, and being able to do that anywhere, right? So that extreme mobility and enhanced mobile broadband, extreme capacity, extreme data rates. It's going to be a lot of enablement in future development that 5G will bring us. And it's just really exciting to see something like this, particularly for me. So it kind of visualizes that I'm very a visual person there. But Jacob, was there anything that stood out to you on this?
Yeah, something we haven't touched on super deep is the low energy cost and low complexity. So, with all these extremely amazing things, you expect it to cost a lot more, but it really just doesn't. It's going to take less time to roll out once it's rolled out officially, and it's going to cost us less energy because of how 5G interacts with each other. It's really quite incredible.
So with some of that enablement, here's some of the things that we're kind of seeing from an application standpoint. So fixed wireless broadband is going to be super real and available from a practicality standpoint. In addition, mobile applications like virtual reality, augmented reality, real-time translation, right? That low latency will really help with real-time translation. Immersive media, really getting into 8K video and using how it can actually enable some applications. We'll actually hit on that real quick in a second. Things you've heard of: drone delivery, connected highways, and autonomous or automated driving. In the IoT space, asset tracking will be a lot easier and have more application. Industrial automation will I think that's going to be a big light up for the manufacturing space. And smart cities is really cool. We can spend a lot of time on smart cities. And then an interesting one that I hadn't heard of until recently: self-managing agricultures, which will be kind of interesting too.
Yeah. Something else to add on here really quick is computing done off sites. We're going to be able to have incredible resources for computing, and the only thing you need to run it inside of your own business is just a screen to be able to stream that information from the computer to you because of how low the latency and how quick the speeds are.
That is cool. That is cool. So let's dream together for just a minute, okay? So what we know can be possible, what we think can be possible. So buckle up. We're going to hit on a couple of these real fast. So new 5G-enabled applications in construction. We've seen this in Australia already. Holographic visualization. Put on a set of goggles, walk around a construction site, and see what it's going to look like, or how that doorway fits within that wall. And it's just really neat to think about what you can do there. Using that really high-res video to be able to do a lot of sensor-based applications as well. And digital induction tracking is a big piece of what can be enabled on a construction site with 5G. And then a lot of the IoT sensors, testing the quality of the job, and like a concrete pour, how well is it going to stand up, and being able to, with the long battery life, embed something in a pour of concrete and leave it there and be able to test it over time. It's kind of interesting to see how that all plays together. So more inventory management, right? Real-time inventory management, and being able to have smart shelving, for example, where you can automatically update what's on the shelf, what's on the shelf, do real-time or just-in-time delivery, which is a big win for most retail and warehousing, and then efficient logistics like that will be enabled, kind of like that just-in-time delivery. There's a lot of really cool logistics things you can do in retail as well. So more retail focused applications, security and compliance. We've talked about some security benefits, but faster checkout with the low latency, you'll have increased trust with that security as well, and then that decreased battery usage will play a big part in the long-term lifespan of that technology. And another retail fun one, this is one that is kind of scary and kind of not, and the next two slides is the Minority Report. So you either love or you hate the idea of Minority Report, right? But some of the cool things in that are going to be enabled by 5G. And one of the things that our team has really come up with that's really interesting is this immersive shopping experience where you can look in a mirror and try on, digitally try on clothes maybe, through augmented reality or immersive experience where the store recognizes you even. That's kind of creepy to me, but the trying on clothes without having to try them on is kind of fun. And then frictionless transactions. So we've seen that in some stores today, but that'll enable even more, not pulling anything out or swiping anything or inserting anything, just walking at a door and the transaction happens. So that's kind of neat. This is kind of cool for first responders. This idea of augmented reality to enable safety. So you can get real-time building data. You're in a building as a firefighter or a SWAT team member. And you've got a helmet on with a heads-up display that tells you where the hot zones are, or whether there's toxic gas in the building, or maybe it's a heat sensor for finding somebody. If you're looking for a specific, lost person, or you're trying to find maybe a suspect, being able to find those things or be able to tell those things in a heads-up display. It's pretty neat to think about all the things you could put into maybe a heads-up display with that low latency and that real-time data, being able to live stream your video back to a command center. So there's a lot of enablement there that I think is super fascinating as well. Smart cities is also a fun one to dream about. So this is one that our public sector team dug into really recently. Gunshot detection sensors enabling sensor queuing, which enables surveillance cameras, which helps to track down and find the culprit, the suspect in a gunshot or in a shooting type of scenario, right? So you could dig into how that all works, but essentially what happens is, you have a gunshot detection system which exists today that triggers sensor queuing, which queues sensors in certain geographies based on the data that's it's gathering from that gunshot detection and telling it where that person is or could be, enabling surveillance cameras in that area that may be able also to have a gunshot residue sensor to be able to tell which person in a crowd has gunshot residue on them. Anyway, there's a lot of fascinating things that you could dig into there as well. But smart cities can be a really big as a new application that 5G is going to enable for us. And then lastly, one of the things that I think will be more tangible for your average consumer is broadcast and production. Not only will the infrastructure for broadcast change to be satellite-less, and those dishes on those trucks will be replaced with 5G connections, but also in broadcast features, which will be really neat to be able to have that low latency real-time data coming from players. Next-gen stats is just going to take another step forward, being able to not only use it for broadcast, but maybe in a game, the team can monitor some new things with some IoT-based sensors on field. So there's a lot of dreaming there. Jacob, real quick, is there anything that stands out to you from your vision of the future with 5G?
Oh gosh, I mean, it's hard to pick one thing. I do love the idea of AR glasses and AR contacts. Like I mentioned before, instead of trying to solve the problem of how do we fit a computer on a set of glasses, instead we just have to figure out how to fit a screen on a pair of glasses and get real-time information for so many uses. I think that really stands out to me, and I think with 5G, the limitation really is your imagination rather than the technology.
Totally agree with that. So if you guys have any interesting applications you've seen, please drop them in the chat. We'd love to see what other elements that we're not highlighting today that you guys are interested in or what you found is super fascinating. Okay. So we might be able to set some time aside for questions for you guys, but what can you do today? Realistically, today we have low and mid bands available. Mid bands are rolling out, but low bands are really available for most of the country right now and multiple carriers. High band will continue to roll out. It will probably be limited to more specific applications. It'll be limited to high density cities and venues, or the NFL cities, which will be the biggest target early on for the carriers. And then local areas and infrastructure will require a different setup for that high band as well. And then I mentioned the NFL cities. So if you live near an NFL team, you'll see that millimeter wave roll out before anybody else does. But when will 5G really impact you? It's probably going to be somewhere near the second half of next year to start. Mid-band is going to be where you're going to see most of the big gains. And if you don't live near an NFL team, then that's probably going to be the first time you'll be able to realistically access a nationwide mid-band network. Jacob, is there anything you want to add to that?
No, yeah. I think we've hit it really hard on millimeter wave. Is around today. If you live near an NFL city or live in a major city, you might be able to go check it out. But otherwise, we might have to wait a little longer on it.
Our director of sales, Gary Manise, has actually given us a really good picture here of what it looks like roadmap-wise for 5G. 2020 for 5G was the year of the promise of 5G, learning about it and what it could do. 2021 is really going to be more about practical 5G, realistic nationwide implementation, infrastructure development, and developing some new next-gen solutions now that it's accessible. And then 2022 is likely when you'll see more of the performance of 5G outside of your consumer or handset applications, because those solutions will have been developed and are realistic from that point forward. How do you learn more about 5G? Well, like I mentioned earlier, we've got a 5G webinar series going on, so stay tuned on our social accounts. Our emails will send out invitations to more 5G seminars coming up on applications and functions and live in-depth information. News and articles, we'll be publishing those throughout the year next year, and social accounts, like I mentioned. We'll also be sharing, information that we're not creating, we're just distributing for you guys as a resource, some bite-sized info. And if you do want to know more about what you can do today, even though 5G isn't necessarily commercial yet, engage with your RCN account manager if you got one, and if you want to work with us on something, we can really paint that 5G pathway for you, figure out what you can do today to enable yourself tomorrow for 5G, and make sure that you're investing in infrastructure with 5G forward capabilities, even if they're not 5G specifically today. As an overview, we can help you guys. We are the technology ally, and we want to be yours. And you can definitely expect more from us than you can any of your other technology consultants. And so we really want to position ourselves as that partner for you guys. And we do promise that, as far as we can help you with anything, we will promise that your tech will work. We'll make sure that you are set up for success, both today and tomorrow in 5G, in the 5G era. And if you do want some more information about that, specifically, we are offering a free 5G consultation. The information here is for our headquarters here, and our director of sales, Gary Manise, will be happy to help set you up with a consultant, and you can actually reach out to him directly to get that 5G conversation started. Our number here is 865-293-0350, or you can hit us up at info@rcntechnologies.com.